5.7 is the binomial theorem. Please write down this Pascal's triangle. For Pascal's triangle, I will not expect you to have this memorized. I will give it to you on, it'll be on the board for the assessments. So right here, how the Pascal's triangle works, notice on the outsides, there's just ones. And then how you get these in between numbers, you go ahead and you're just adding. So 1 plus 1 is 2. We put 1 on the outside, so 1 plus 2 is then 3. 2 plus 1 is 3. Again, the ones just are automatically on the outside, making it that triangle shape. But to get these in between numbers, you're just adding the two numbers and putting what the sum is in between. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then put 1 on the outside. Start with our 1, add these. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then put a 1. So then if we wanted to do another row and continue this, row 7, we would put a 1 on the outside. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. And then we would put 1 on the outside. So the triangle continues to get larger and larger, but we're going to stop here, and hopefully you see that pattern. So when we use this Pascal's triangle is examples like this. When it says factor x plus y to the second power. Now, x plus y to the second power is the same thing as x plus y times x plus y. I could go through and just FOIL that. X plus y times x plus y. So distribute this x times x is x squared, x times y is xy, y times x is xy, y times y is y squared. And then combine my like terms, so these two middle terms are like terms. So 1xy plus 1xy is 2xy. So that would be my final answer. Now, another way I could do this is using this Pascal's triangle. So this exponent, whatever it is, I go to that row number. So I would go to row 2. I write down those numbers 1, 2, and 1. I'm going to expand those out. So I put a 1, a 2, and a 1. And then from behind it, I put my two terms, so an x and a y. And I'm going to put those in parentheses, an x and a y in parentheses, an x and a y, an x and a y. And then I put my exponents. So it's to the second power, so I start with 2, and I'm going to count downwards with my x's. So 2, 1, and 0. Then with my y's, I'm going to start with 0 and count up. So 0, 1, 2. Now it doesn't matter which variable you count up and which one you count down, but you need to go in opposite directions is the key. And then you go through and simplify each term. So anything to the 0 power is just 1. So I have 1 times x squared times 1, which is just 1x squared. 2 times x times y, so 2xy. 1 times y squared is just 1y squared. And notice I get that exact same answer. Now for this one, since it's only to the second power, it's probably going to be quicker just to go ahead and distribute or FOIL. But let's take another look. If it's to the 6th power, am I going to want to choose method 1 and write this out 6 times and then go through and FOIL all that? Probably not. So Pascal's triangle is a lot quicker for a problem like this when the exponent is higher. So the first thing we go, this is to the 6th power, so I'm going to go to row 6. I'm going to write those numbers down. So then I have spread them out, 1, 6, 15, 20, 15, 6, and 1. And then I go through and I put my exponents after. So I put my variables, a and a b in parentheses after each one. And then now my exponents. So I start with 6, I'm counting down to 0 for my a's. And then my b's, I'm starting with 0, and I count up to 6. And then from here, I'm close to having the correct answer. I just need to simplify any term that needs simplified. So anything to the 0 power is just 1. So 1 times a to the 6 times 1 is just 1a to the 6. This term is simplified. This one's simplified, 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 simplified. And then this last one we have to the 0 power again. So 1 times b to the 6 is just 1b to the 6. And then that would be my final answer. So you'll notice that once you get the hang of Pascal's triangle, it is going to save you lots of time. Let's try another one. So we have 3x minus 2 to the 5th power. So we're going to go to Pascal's triangle. We go to row 5, which is 1, 5, 10, 10, 5, 1. I expand those numbers out, and then I put my variables. Since the first one is 3x, I put 3x in one set of parentheses and negative 2 in the other set of parentheses. And I put that after each of the numbers. And then I put my exponents. So I'm going to start with, this is 5, so start with 5, count down 4, 3, 2, 1, and then 0. Then I start with 0 for my negative 2, and I count up to 5. Now I need to go through and simplify this. Now notice the 3x is all to the 5th power, so that means 3 is to the 5th power and x is to the 5th power. So I would have 1 times 3 to the 5th power times x to the 5th power, and the negative 2 to the 0 power is 1. So that would just reduce down to 243x to the 5th. And then this next one, I add 5, 3 to the 4th power would give me 81. And then negative 2 to the 1st power is negative 2. So I'm going to multiply those out. 5 times 81 times negative 2, and I get negative 810. And then the x to the 4th, I tack that variable on the end. And then I go to the next one. So I have 10. 3 to the 3rd power would give me 27. X to the 3rd power gives me x to the 3rd power. Negative 2 to the 2nd power is positive 4. So 10 times 27 times 4 gives me 1,080. And then that x to the 3rd, the variable, you tack it on the end. Go to the next one. So I have 10. 3 to the 2nd is 9. X to the 2nd is x squared. Negative 2 to the 3rd is negative 8. So 10 times 9 times negative 8 is negative 720 x to the 2nd. And you keep going through. Make sure the variables go at the end of each of them. Anything to the 0 power is always just 1. So like this one, 3x is all to the 0 power, so that would just be 1. So it's 1 times 1, and the negative 2 to the 5th power. Make sure you put that in parentheses to the 5th power, and you get negative 32. So 1 times negative 32 is just negative 32. So that would be our final answer. I have one more for you. 2x minus 3 to the 4th power. I'm going to give you some time to go through and try the process, so please pause. And when you're ready, please check your work with mine.